Okay, so dear friends, we did quite a lot on differentiation. We did quotient rule, we did the product rule, we did addition rule, subtraction rule, chain rule, composite functions. Now we move to one more type of function, that is log functions. But before we move over to log, we need to once more revise what exactly logarithm means. So suppose you have a raised to b is x, which means that, so hence we have a raised to b is x. So suppose you have 2 raised to 6 is 64, which means you write it as log 64 to the base 2 is 6. Same way here, log x to the base a is b. So a raised to b is equal to x. So that means log of the power to the base is equal to the index. So this is the concept of log. So what is the importance of log in derivatives? Now suppose many functions are logarithmic. Suppose you have y is equal to x raised to 3x or something. Now in these cases, how can we find? We have done cases wherein a constant has been raised to a variable, or a variable has been raised to a constant. We have standard, but here you have a variable raised to a variable. In such cases, we have to use the concept of logarithmic functions. Now let's quickly revise what exactly log again means. As I said, you have a raised to b c, which means log c to the base a. C, that is a power to the same base, is equal to the index. So 2 raised to 4 is 16. That means log 16 to the base 2 is 4, which means 2 raised to 4 is 16. Similarly, 10 cube is 1000, which means log 1000 to the base 10 is equal to 3. 5 raised to minus 3 is 1 by 125. That means log 1 upon 125 to the base 5 is minus 3. Now in this, there are certain rules which we need to realize over here, that log of b to the base a is the same as 1 upon log a to the base b. That means when you interchange the log and the base, they are reciprocals of each other. Then of course we know this particular rule, log ab is nothing but log a plus log b. So we have also common logarithm wherein the base is 10, where when you use a log table and all. And you have the natural logarithm, which is to the base e. So you have similarly log of a by b is nothing but log a minus log e, and log of anything to the same base, e to the base e, log 2 to the base 2, log 3 to the base 3, or 10 to the base t. It's understandable. 10 raised to 1 is t, 2 raised to 1 is 2, e raised to 1 is 2. So log of any numbers to the same base is 1. Then of course, log of a raised to m is nothing but m log a. Then we have certain change of base rules. Suppose you have log of b to the base m. Now suppose I want to change this base to say n. We can write this. This is the same as log b to the base n divided by log m to the base n. And if we combine it with this rule, we can write this as log b to the base n, as in the numerator. 1 upon log m to the base n is nothing but log n to the base m. Hence we have these basic rules of log which we shall use again. And also remember one more rule, e raised to log m. So if you have is nothing but m itself. This also is a particular rule which we have. Anyway, so if we just brush up these rules, let's see what we have. So as said over here, I told you log mn to the base a is nothing but log m to the base a plus log n. However, candidates should remember log m into log n is not the same as this. So it's log mn to the base a. Similarly, log m by n to the base a is log m to the base a minus log n. Similarly, if you are raising a power, the power will go. This, of course, I told you the rule that log a to the base b is the same as 1 upon log b to the base a. Hence, when you cross multiply, log a to the base b into log b to the base a is 1. And log of any number to the same base is 1. Log of 1 to any number is 0 because a raised to 0 in any case is 1. Then a raised to log b is the same as b raised to log a. So these rules we need to remember more often. And the change of base rule, of course. So see, rule of changing base, I told you. Log m to the base a is the same as log m to the base b upon the log a to the base b. This can be written as log m to the base b. Since it is 1 upon log a, we can write this as log b to the base a. So log m to the base b, so hence we get it like this, or we get it like this. Yes, log m to the base b is log m to the base a, log b to the base a. So on that basis, suppose you have something like this. How can we solve this? So this can be now written as log 2 to the base 10. And you can write this as 2 log 10 to the base 4 divided by log 8 to the base 4. Now this alone we can simplify it, and suppose you want to change this to the base 4, we can write it as log 2 to the base 4. We are using this particular rule, log 2 to the base 4 upon log 10 to the base 4. So log original log 2 to the new base upon log of old base to the new base. The remaining things are remaining log 10 to the base 4. Now this can be written as log 2 cube to the base 4. Now here this and this are getting cancelled. This is log 2 to the base 4 into 2 upon 3 log 2 to the base 4. You are using the rule log of any number to a particular index. That index becomes a coefficient. Again, log 2 to the base 4, log 2 to the base 4 gets cancelled and you get 2 by 3. Now, these are things which have already been covered in logarithms, but nevertheless, we can get just a reminder. Now, how do we use the various cases in these cases? So, we'll be taking up some cases over here. How we can use the rules of log. Now, you see y is equal to x raised to x. Now, as I told, we have standard formulae. If it is y is a raised to x, you know dy by dx, that is f dash x in such cases a raised to x into log a. You know this. Similarly, if y is equal to x raised to a, we can write ax into a raised to minus 1 into ax raised to a minus 1. But suppose you have something like this. Then what do? We take logarithms on both sides. Log y is equal to log x raised to x. Now, this can be hence written as log y is equal to x log x. Then we can use the chain rule to use this particular, we can use a chain rule to find the derivative. Now, differentiating, we say differentiating with respect to x. So, derivative of log y will be 1 by y into d by dx of y, that is dy by dx. Here you use chain rule, x into d by dx of log x plus log x into d by dx of x. So, this becomes hence dy by dx would be y into x. You're cross multiplying this here. So, x into derivative of log x is 1 by x plus log x into derivative of x, that is 1. This gets cancelled. So, eventually this becomes y, that is x raised to x into 1 plus log x. Hence, d by dx of x raised to x is nothing but x raised to x into 1 plus log x. So eventually you are taking the logarithm on both sides and going about doing this. Now suppose you have something like this. Let's see, this is going one step further. So we have y is equal to x raised to x raised to x. So again take log y. Log y is x raised to x log x. Now before we do this, we need to find the log of this for chain rule. So you can take u is equal to x raised to x. We did this of course, but just to remember, log u is equal to x log u, right? So in that case, taking dy by dx, du by dx, 1 by u is equal to 1 by u into du by dx, x into log u. Yes, so this will give you log u. X into log u, so x into du by dx plus, x into log u. So it's going to be x into 1 by u I'm sorry, I think we made a mistake here. So it's going to be x log x. I'm sorry. So it's going to be x into 1 by x plus log x into derivative of x1. So du by dx is, hence this gets cancelled, is equal to u, that is x raised to x, so cross multiplying, into 1 plus log x. Okay, so we already found also d by dx of x. Now here we do the same thing. So this will become 1 by y dy by dx, x raised to x into d by dx of log x plus log x into d by dx of x raised to x. Now 1 by y dy by dx remains as it is. Let's simplify this. X raised to x into 1 by x plus log x, and x raised to x, we already found the derivative is nothing but x raised to x into 1 plus log x, right? So in this we can take out, so this will give you dy by dx is hence equal to y, which is x raised to x raised to x into, you can take x raised to x common, into 1 by x plus log x into 1 plus log x. This is what you get. You can simplify this further. Remember, this is one thing. This is x raised to m into x raised to n. So this can be written as x. So we have x raised to x. Yes, so we have x raised to x. This is x raised to x. Okay. So this can be, in this we can even take out log s common. So you get x raised to x, x raised to x, x raised to x. So you can even take log x common. So you get 1 upon x log x plus 1 plus log x. So hence you can even write this as x raised to plus x into log x into 1 upon x log x plus 1 plus log x. So eventually you are using the chain rule and also using the concept of logarithms. Okay, let's see another example. Okay, now here you have like this. So we have y is equal to x raised to x raised to x raised to x infinity. So log y hence would be x raised to x raised to x raised to x up to infinity into log x. Now this alone is y. So we can write it as log y is equal to y log x. Log y is nothing but y log x. Now hence if you see, take as the derivative on both sides, so you get 1 by y dy by dx is equal to y into derivative of log x, that is 1 by x, plus log x into derivative of y, that is dy by dx. So you can take to this side, so you get dy by dx into 1 by y minus log x is equal to y by x. Hence, if you simplify this, dy by dx is into 1 minus y log x upon y is equal to y by x. So if you get this term here, dy by dx is equal to y square upon x into 1 minus y log x. Hence you get accordingly the same y by x, yes, log y is equal to y log x, so y into 1 by x plus log x into dy by dx. So we collect these two terms together, dy by dx, 1 by y minus log x, so 1 minus y log x, cross multiply, and you get dy by dx is y square upon x into 1 minus y log x. Alright, now let us take this. Now here we need to find the derivative of each of these separately, because if you directly do log y on both sides, it will become a little difficult. So we are going to use, you can take u be equal to x raised to x and let v be equal to x raised to 1 by x. So in that case, log u is nothing but x log x, and log v is nothing but 1 by x log x. Now take derivative on both sides, so you get 1 by u du by dx is equal to x into derivative of log x, that is x into 1 by x, plus log x into derivative of x, that is 1. We do this. Here also we get 1 by v dv by dx is equal to 1 by x into derivative of log x, that is 1 by x, plus log x into derivative of 1 by x, that is x raised to minus 1. So it's going to be minus 1 into x raised to minus 2, that is minus 1 by x square. Therefore, du by dx would be u into 1 plus log x, and dv by dx would be v into 1 by x square minus 1 by x square log x. Right? Now this again can be written as du by dx is u. U is nothing but x raised to x into 1 plus log x, and dv by dx is x raised to 1 by x upon x square into 1 minus log x. This can eventually write this x raised to 1 by x minus 2 1 minus log x. Now dy by dx is nothing but du by dx plus dv by dx. So these things are ready for us. So this is x raised to x into 1 plus log x plus x raised to 1 by x minus 2 into 1 minus log x. So this is how we can find the derivative of these terms using the concept. So you can see how logarithmic functions can be differentiated and what the importance of logarithm is, because we have a case wherein x has been raised to a variable. So the standard formula x raised to n does not work here. Hence we have to use the concept of logarithms or logarithms to find this. Okay, now here what do we have? Similar manner we have, we take u as x raised to x square and v is x raised to x cube. So students, just keep your pencils ready and try along with you. Pencils, pens with a sheet. So you get log u, which is x square into log x, and log v is x cube into log x, right? Now differentiate with respect to x, both of them. Okay, so this will give you 1 by u du by dx. Using your chain quotient rule, x square into derivative of log x, that is 1 by x, plus log x into derivative of x square, that is 2x. Okay, then this one would be 1 by v dv by dx, x cube into derivative of log x, that is 1 by x, plus log x into derivative of x cube, that is 3x square. So therefore we get here du by dx, this becomes x. So u into x plus 2x log x, and dv by dx is v into x square plus 3x square log x. We can still take out common terms. U is nothing but x raised to x square, and again you can take x common and you get 1 plus 2 log x. This is going to be dv by dx is v, which is x raised to x cube. You can take x square common and you get 1 plus 3 log x, which will be eventually x raised to x square plus 1 into 1 plus 2 log x, and this will be x raised to x cube plus 2 into 1 plus 3 log x. Hence, since dy by dx is going to be du by dx plus dv by dx, we get this as x raised to x square plus 1. Remember, the plus 1 is in the index, into 1 plus 2 log x. This is du by dx plus x raised to x cube plus 2, again in the index, into 1 plus 3 log x. Hence, this is our dy by dx.